Hey guys, I'm going to continue part two. It's the end of the day, so I just couldn't do it all in the morning. So we're going to graph a circle and how to tell the center. So ironically, you find the center first, but let me just make an equation up. So x minus 1 squared plus y plus 2 squared equals 9. And in this one, we're going to find the center first, technically. So to find the center of the circle, we're just going to take the value next to the x and the value next to the y and flip the signs. So this is going to be -1. And instead of -1, it's going to become +1. So that's a 1, comma, instead of +2, it's going to become a -2. So my center is literally this value and this value. The one with the x goes with the x, the one with the y goes with the y. So 1, comma, -2. So 1 right, 2 down. Then we're going to find our circle or my radius. The radius is r squared. It's the thing on the right side. So if r squared equals 9, r equals technically ±3. But because we're talking about distance or like an actual movement, that's only a positive movement. So it's only +3. So the only significant one we care about is 3. So that means I'm going to go 3 right, 1, 2, 3. 3 left, 1, 2, 3. 3 up, 1, 2, 3. Remember, you're making a circle, so you want to go all directions. And then 3 down, 1, 2, 3. And then from there, I'm going to cheat using a little tool here, but on your paper, you just draw a circle as best as you can. See, like my lines will work, so yeah, kind of. But either way, like a really big dot. But either way, it should hit all 3 circles, so you just make a circle as best as you can. Okay, doesn't matter if it's sloppy or not. But the points should match. You identified the radius, you identified the center. That should all be the same. So for this one, we're going to do find a line that goes to 3, 2, and that's parallel to 4x minus 5. So when you see the word parallel, you got to take the slope from this one, which is 4x minus 5. So the slope here is 4. And then you're going to make a line, y equals mx plus b, using this point. So you take the slope from the one line or the one equation and put it with this point to make a new equation. So 2 equals 4 times 3 plus b. 2 equals 12 plus b. -10 equals b. So -10 equals b. So then we're going to make an equation. Y equals 4x minus 10. So my new equation is y equals 4x minus 10. Over here, though, we have perpendicular. Perpendicular means I'm going to do the negative reciprocal of the slope. So since the slope here is 3, I need to do the negative reciprocal of it. So I'm going to flip it over, which is 1 over 3. And since it was positive, it becomes negative. If it was negative, it would become positive. So it's -1 over 3. But the same concept, I'm going to take the point and the slope that I identified, which is over here, and plug it into y equals mx plus b. So 2 equals 1/3, -1/3, times 6 plus b. -6 over 3 equals -2. I should have done that on the side. -1/3 times 6 is -2, plus b equals 2. Add 2 to both sides, 4 equals b. So your answer here is y equals -1/3. You keep the slope from that you used over here. X plus the 4 I just found. That's my new equation. All right, the next one. What makes something a function? So what makes something a function? You remember the golden rule. Every input should only have one output. Every input should only have one output. So how to check for algebraically? What you always are going to do, I guess I'll write it as a step, solve for y. You're going to solve for y to check when we have like an equation. I'll show you that. But solve for y. And if you end up with a plus minus, then on the x side, then it is not a function. So I'm going to show you an example of where that happens. So for example, x plus y squared equals 1. Let me solve for y. So solve for y means get y by itself. So I'm going to subtract x on both sides. So y squared equals negative x plus 1. If you wrote 1 minus x, that's totally fine. Then I have to square root both sides. So when you square root both sides, you got to remember you're going to do the plus or minus the square root of negative x plus 1. And this negative plus or minus over here means that is not a function. So if you get a plus or minus, it's not a function. Usually that's going to happen when you have a y squared over here. Another example where that happens, if you have, and I'll make it a little bit simpler, y absolute value. Let's do it like this. Absolute value of y plus 3 equals x minus 1. So absolute value of y plus 3 equals x minus 1. Subtract 3 on both sides. Absolute value of y equals x minus 4. When you get rid of an absolute value, so to get rid of an absolute value, you have to add a plus minus on both sides. So what it becomes is y equals plus minus x minus 4. So because the plus minus exists here and it's x minus 4, y equals plus or minus x minus 4. What that causes it to show you is because you have the plus minus, it is not a function. So if you solve for y and it has a plus minus, you know it's not a function. I should give you an example of one that is a function. Very quickly, let's do y plus x squared equals 1. In this one, I'm going to subtract x squared on both sides. I solved the y, so y is by itself, and it didn't cause a plus minus to occur. There's a negative here, there's a positive here, the negative here and a positive here, but that's not a plus minus in the way. So typically you could actually tell if your y is an absolute value or your y is in a even power. So the second power, the fourth power, the sixth power, those things will instantly tell you that is not a function. So that is not a function. Next stuff is a bunch of plug-in function stuff. So let's say f of x is 3x plus 2. I'll say g of x equals 7x minus 1. Okay. In this one, when I have a f and whatever I plug in here, let's say a 2, I replace every x with a 2. So 3 times 2 plus 2, 6 plus 2, 8. So f of 2, you change the x to a 2. Even if I put something bigger, like x minus 1, I'm going to replace every x with x minus 1 in this case. So 3 times x minus 1 plus 2. 3x minus 3, I distribute that 3, plus 2, plus 2, and then that's going to be 3x minus 1. Okay. If I ask you, please give me the value of x that makes f of x equal 11, for example. So notice how the x is not on the inside here. Notice how the x is not on the inside here. It's on the outside. That means I'm going to replace the f of x itself, with 11. So that's going to be 11 equals 3x plus 2. And it just becomes a two-step problem. Minus 2 on both sides, 9 equals 3x. Divide by 3 on both sides, x equals 3. So if I have f of x equals 11, that replaces the f of x itself. I have a f of 2, that replaces the x. If I have f x minus 1, that replaces the x. Actually, let's keep it here. on the side. Now, if I told you something along the lines of if f of x equals g of x, give me the x value that makes that happen. What I'm going to do is just simply plug it in where where I have f of x, which is 3x plus 2, equals the g of x, which is 7x minus 1. So all I do is set them equal to each other. Then I solve like an algebra problem. 3 over here, 4x over here. X is going to equal 3/4. 3/4. So if I have f of x and g of x, that must mean they're equal to each other. Let's see, is there anything else? No, that's pretty. Oh, I should mention domain. I kind of skipped through it the last time just because it was kind of simple. But the domain, I'll use the table again. This is how you tell a domain. If you have 1 over x, that is where x cannot equal 0. So your domain is x does not equal 0. If you have a square root of x, it cannot be negative. So this is x greater than 0. So whatever here, it has to be greater than 0. And if you have 1 over the square root of x, in this situation, it's going to be, this is greater than or equal to, because technically it could be 0. This is just xn greater than 0. So this is greater than or equal to because it could be 0. While here, it can't be 0, nor it can't be negative. So it's x is just bigger than 0. Very quick examples of these things. I'll put it on the right over here. 1 over x squared minus 4, which I think is literally the one I gave you in the past on your test. So you try to figure out what causes the bottom to be 0. So you set it equal to 0. Plus 4 on both sides and square root. X equals plus or minus 2. You could also factor, by the way. You could do x minus 2, x plus 2. But x equals plus or minus 2. So the domain here, the domain is x does not equal plus or minus 2. So your domain is cannot be plus or minus 2, because if you put a positive 2, you get 4 minus 4, which is 0, not okay. And if you plug it in negative 2 squared is positive 4, 4 minus 4 is 0, not okay. Square root of x minus 5. So then, same thing, I'm just going to set x minus 5 equals 0. So add 5 to both sides, x equals 5. That's what causes it to be 0. So anything bigger than that is okay. So domain has to be x is greater than or equal to 5, because it has to be bigger than 5. It could be exactly 5. It's okay to be 0. And then the last one, 1 over the square root of x squared plus minus 2. Yeah, minus 9. Minus 9. So here we try to figure out where x squared minus 9 is. Has to equal 0. Oh, actually, no, let's not do that one, because actually that causes an inequality. Let's make it a really easier one. I'll make sure on the test it's easy too. Let's do an easier one. Square root of x plus 10. So x plus 10 equals 0. X equals negative 10. Remember, I have to be bigger than 10, so I don't cause it to be 0. So x is greater than negative 10. The domain is x is greater than 10. Good. All right, that should cover everything. I'm going to post some homework problems, or not homework problems, textbook problems. And you can do that for practice. I think our test is Tuesday, so Monday we'll just do all review. Use this to your advantage, and good luck on your test. Have a wonderful weekend.